This video is going over the last example in the lesson on Taylor series. I believe it's lesson 19. Okay, so use a Maclaurin polynomial. Now remember, a Maclaurin polynomial is just like a Taylor polynomial, except it's when a equals 0. To estimate e to the 0.4 with error less than 0.0001, and you may assume that e is less than 2.72. Now, first of all, we're estimating e to the 0.04, but we need a function in terms of x. So girls, fx is just e to the x, but our x value that we're going to find an estimate of is 0.4. And because it's a Maclaurin series, a is 0. So what is our Taylor polynomial or Maclaurin polynomial? That will approximate this. So remember, Tn x equals, from k is 0 to n of, now it's f of k of usually a, but in this case 0, over k factorial times x to the k, which is usually x minus a to the k, but because it's Maclaurin, a is 0 again. Okay, so that's the function. Now, the good news is f of 0 is e to the 0, which is 1. And f dash of 0 is also e to the 0, which is 1. In fact, f of any degree of derivative of 0 is e to the 0, which is 1 in this case. So that works out really nicely. So our Taylor series is just k is 0 to n of x to the k over k factorial. Now, we want the error to be less than 0.00001. So the question is, what is the error? And then I can find the degree that I need my Taylor polynomial to be. So the error, if you remember, n is the x value, which in this case is 0.4. We write dot dot the a value, which is 0 in this case. And that would equal, now if you remember, it's f of, I'm going to write this other version, f of n plus 1, the n plus 1th degree of f, but it's in terms of c, a constant term which we don't know what it is. And then we have 0.4 or x to the n plus 1, all over n plus 1 factorial. And now wait a minute. The derivatives of fx is always e to the x, so then if you put c in it, for this first part here, you'll get e to the c, times 0.4 to the n plus 1 over n plus 1 factorial. Now we have to remember c, by definition, c is in the interval from, now what's smaller out of 0.4 and 0? 0. And, this should be an open interval, I apologize. C is within the open interval from 0 to 0.4, or as you know it, a to x as well. If c is within there, so we're told in the question, is less than 2.72. So let's think about e to the c. Let's look at it at the two extremes. E to the 0 is equal to 1, which is also less than 2.72. And e to the 0.4 is going to be definitely less than 2.72, because e to a power less than 1, it actually reduces the value. So for instance, e to the half would be the square root of e, which is smaller than e. So e to the 0.4 would also be smaller than e, which is also less than 2.72. So my point is, that means r, that we wrote down a second ago, would be less than, I can replace EC with e to the C with 2.72, and this would be, and the original error would be less than that. I'm subbing in now a larger value than the original, therefore the error would be less than 2.72 times 0.4 to the n plus 1 over n plus 1 factorial. Okay, do you understand, girls? Basically, for e to the c, and I don't know what c is, so I kind of need to find a limit to it so I can get rid of c. And I realized e to the c is always going to be less than 2.72, which means, if it helps, this is less than 2.72 times 0.4 to the n plus 1 over n plus 1 factorial. Therefore, the error, which is here, is less than that expression. So hopefully that makes sense. But wait a minute, I want all of that to be less than 0.00001. Now, the good news is you can solve this graphically, this equation graphically using your GDC. We're going to assume this is a paper 2 question, or paper 3, but that's got a calculator in, obviously. And so, girls, think about it. You could either solve it using NSolve, or you could graph this side, like y equals 2.7 to 0.4 to the x plus 1 over x plus 1 factorial, and also y equals 0.00001, and the point of intersection is going to tell you the value of n. Now, when I did that, I found that n must be bigger or equal to 6. So if that's the case, then we can finally use this Taylor polynomial, using this from k is 0 to 6. So it becomes, we end up estimating e to the 0.4 equals approximately the sum from k is 0 to 6 of 0.4 to the k over k factorial. Now, you could do this term by term and then add them up in your calculator, or you can actually put this whole sum in your calculator, press the symbols button, and you can actually choose the sigma or the sum notation and enter all these things in there and let it do the whole thing for you. And you will get 1.491824356.